something about Saturn feels off. For most of human history, Saturn felt reliable, distant, elegant, predictable. A planet defined by symmetry and balance, wrapped in rings that looked eternal and unmoving. Even as telescopes improved and spacecraft flew past, Saturn retained an aura of stability. It was massive, ancient, and seemingly indifferent to time. That sense of reliability is now quietly collapsing. Over the last 2 decades, scientists have been forced to confront a disturbing realization. Saturn is changing in ways they did not predict, cannot fully explain, and are increasingly uncomfortable with. These changes are not cosmetic. They are not surface-level curiosities. They involve Saturn's atmosphere, its rings, its magnetic field, and the delicate balance that holds the entire system together. And the deeper scientists look, the more unsettling the picture becomes. Saturn is not slowly evolving in a predictable way. It is behaving erratically. Patterns are breaking. Structures are shifting. Long-standing assumptions are failing. The most troubling part is not that Saturn is changing. All planets change. The problem is that these changes appear to be accelerating, interconnected, and poorly understood. Saturn is doing things it should not be doing, at least not according to the models scientists trusted for decades. When Saturn stopped acting like Saturn. The first hints that something was wrong did not arrive as a dramatic discovery. They arrived quietly, buried in long-term data. Saturn's atmosphere, once thought to be relatively stable, began showing patterns that refused to repeat as expected. Seasonal changes were anticipated. Saturn takes nearly 30 Earth years to orbit the Sun, and its tilt creates long seasons. Scientists expected slow, predictable atmospheric shifts. Instead, Cassini observed storms that formed out of season, expanded far beyond predicted boundaries, and then vanished without clear explanation. The most famous of these events was the Great White Spot, a massive storm that erupts roughly once per Saturnian year. Cassini caught one in unprecedented detail, and it did not behave the way previous records suggested it should. The storm grew faster, spread wider, and interacted with surrounding atmospheric bands in unexpected ways. Even more troubling was what happened afterward. The storm left behind long-term disruptions in Saturn's jet streams, altering wind patterns that had appeared stable for decades. Saturn's atmosphere did not simply recover. It reorganized. This was the first warning that Saturn's internal systems were not as steady as once believed. The hexagon that refuses to make sense. One of Saturn's most famous features is the hexagon at its north pole, a 6-sided jet stream unlike anything seen on any other planet. Discovered decades ago, the hexagon became a symbol of Saturn's strangeness, but also of its consistency. It appeared stable, locked in place, rotating with the planet like a cosmic machine part. Cassini changed that perception. Over time, the hexagon showed subtle but undeniable changes. Its color shifted from blue to golden hues. Its internal structure evolved, and most importantly, its behavior did not match existing models of fluid dynamics. The hexagon's persistence alone is a problem. According to theory, such a structure should break down over time. It has not. Instead, it appears to be responding to deeper changes in Saturn's atmosphere and internal heat flow. Some scientists now suspect that the hexagon is not a surface phenomenon at all, but a visible symptom of processes occurring far beneath the clouds. That possibility opens a troubling door. If Saturn's internal dynamics are shifting, then surface changes may only be the beginning. Saturn's atmosphere is rewriting the rules. Cassini's long-term observations revealed that Saturn's atmosphere is far more dynamic than expected. Wind speeds varied unpredictably with altitude. Chemical compositions shifted over time in ways that did not align with seasonal models. temperature gradients behaved inconsistently, suggesting changes in internal heat transport. Saturn emits more energy than it receives from the Sun, a fact known for decades. What Cassini revealed is that this internal heat is not being released evenly or predictably. Instead, it appears to surge and redistribute in pulses. These pulses may be driving atmospheric instability on a global scale. Storms erupt, jet streams shift, and cloud layers reorganize. Saturn is not simply responding to external factors like sunlight. It is actively reshaping itself from the inside out. This realization has forced scientists to reconsider how gas giants evolve. Saturn may not be slowly cooling into equilibrium. It may be undergoing episodic internal changes that disrupt surface stability. The rings are not as permanent as we thought. Perhaps the most unsettling discovery involves Saturn's rings. For centuries, they were assumed to be ancient, stable features, possibly as old as the planet itself. Cassini shattered that assumption. By measuring how much ring material was falling into Saturn's atmosphere, scientists discovered that the rings are losing mass at an alarming rate. This phenomenon, known as ring rain, revealed that charged particles from the rings are being pulled along magnetic field lines and deposited into Saturn's upper atmosphere. The rate of this loss suggests that the rings may be far younger than previously believed, possibly only a few 100 million years old. Even more disturbing is the implication that they are temporary. If current loss rates continue, Saturn's rings could fade significantly on timescales that are short by cosmic standards. This means Saturn's most defining feature is not permanent. It is transient, and the process driving its disappearance is ongoing right now. Saturn is literally consuming its own rings. A magnetic field that won't sit still. Saturn's magnetic field was once considered one of the simplest in the solar system, nearly perfectly aligned with its rotation axis. This simplicity made Saturn a useful reference point for studying planetary magnetism. Cassini complicated that picture. Precise measurements revealed subtle asymmetries and fluctuations that defied explanation. Even determining Saturn's true rotation rate became a challenge, because the magnetic field no longer provided a consistent signal. Something inside Saturn is shifting, altering the magnetic field in ways that scientists cannot fully model. Magnetic fields are generated by motion deep within a planet, typically involving conductive materials and rotation. Changes in Saturn's magnetic field imply changes in its interior. This raises uncomfortable questions about the planet's internal structure and long-term stability. If Saturn's magnetic field is evolving, then the processes driving it may also be evolving, with consequences that extend outward to the rings and moons. Why scientists are genuinely concerned. None of these changes exist in isolation. That is what makes them troubling. Atmospheric instability, ring erosion, magnetic anomalies, and internal heat fluctuations all appear to be connected. Saturn is not experiencing a single anomaly. It is undergoing a systemic shift. Scientists are cautious about using dramatic language, but privately, many acknowledge that Saturn is behaving in ways that challenge fundamental assumptions. The models used to describe gas giants rely on equilibrium and gradual evolution. Saturn is showing signs of neither. Instead, it appears to be in a transitional phase, reorganizing itself on multiple levels at once. The problem is that scientists do not know what comes next. Will Saturn settle into a new equilibrium? Or are these changes the early signs of a larger transformation? There is no precedent to guide us. The timing could not be worse. Cassini ended its mission in 2017, just as many of these long-term changes were becoming impossible to ignore. The spacecraft that provided the most detailed view of Saturn ever achieved is gone. There is no immediate replacement. No orbiter currently monitoring Saturn's atmosphere, rings, and magnetic field in real time. Scientists are left analyzing old data, trying to extract patterns from observations that have already ended. Saturn is still changing, but humanity is no longer watching closely. This creates a sense of unease within the scientific community. The planet is entering a period of instability, and our best tools are gone. Future missions are discussed, but none are imminent. Saturn may continue evolving unchecked for decades before another spacecraft arrives. What we are left with. What remains are Cassini's final observations, frozen in time. They show a planet in motion, a system out of balance, and a future that is increasingly uncertain. Saturn is not breaking apart. It is not about to collapse. But it is changing in ways that matter, and those changes challenge our understanding of how giant planets behave. The real danger is not that Saturn will do something catastrophic. The danger is that it will quietly rewrite the rules while we are not paying attention. And by the time we return, the Saturn we thought we knew may be gone. The moons are responding too. One of the most unsettling realizations to emerge from Cassini's data is that Saturn's changes are not confined to the planet itself. Its moons appear to be responding as well. Enceladus, once considered an unremarkable ice-covered satellite, revealed active geysers ejecting water vapor and ice grains into space. These plumes are not random. Their intensity appears to vary over time, influenced by Saturn's gravity and internal dynamics. As Saturn's gravitational field subtly shifts, the tidal stresses experienced by Enceladus change, potentially altering the moon's internal heating. This suggests a feedback loop between planet and moon, where changes in Saturn's interior may be influencing geological activity far beyond its atmosphere. Titan, too, shows signs of long-term variability. Cassini observed changes in cloud formation, rainfall patterns, and atmospheric circulation that did not align cleanly with seasonal expectations. Titan's climate appears more sensitive and reactive than models predicted. If Saturn's internal heat output and magnetic environment are changing, those changes could propagate outward, subtly reshaping the environments of its moons. This interconnectedness raises uncomfortable questions. Saturn is not an isolated object. It is the central engine of a complex system. When that engine changes behavior, everything around it feels the effects. A planet out of thermal balance. At the heart of Saturn's transformation lies a problem scientists still cannot solve. Saturn emits significantly more energy than it receives from the Sun. This excess heat has long been attributed to slow gravitational contraction and internal processes. Cassini revealed that this heat is not escaping uniformly. Instead, it appears to be released in uneven bursts, creating temperature anomalies in the atmosphere and potentially altering global circulation patterns. These thermal imbalances may explain why Saturn's storms behave unpredictably and why jet streams shift without warning. If Saturn's interior is reorganizing itself, perhaps through changes in layer composition or heat transport mechanisms, then the planet could be entering a new phase of evolution. This idea is unsettling because it challenges the assumption that gas giants reach a stable equilibrium early in their lifetimes. Saturn may still be adjusting, even after billions of years. If true, this has profound implications for our understanding of planetary life cycles. Saturn may not be winding down. It may be restructuring. The rings as a warning sign. The ongoing loss of Saturn's rings may be more than a cosmetic change. Cassini's measurements of ring rain revealed that material from the rings is actively interacting with Saturn's atmosphere and magnetic field. This interaction alters atmospheric chemistry and could influence cloud formation and electrical activity. As ring material falls inward, it adds mass and momentum to Saturn's upper layers, potentially affecting circulation patterns over long timescales. The rings are not just disappearing. They are actively participating in Saturn's transformation. The fact that the rings may be relatively young suggests that Saturn's current appearance is temporary. The planet we see today is not the planet that existed 1 billion years ago, and it will not be the planet that exists 1 billion years from now. This realization undermines the comforting notion of planetary permanence. Saturn's most iconic feature is not a timeless constant. It is a phase. Magnetic instability and the unknown interior. Saturn's magnetic field remains one of the most puzzling aspects of its behavior. Cassini's data showed subtle variations that do not fit cleanly into existing dynamo models. The near-perfect alignment of Saturn's magnetic field with its rotation axis complicates efforts to measure the planet's rotation rate, a fundamental property scientists once assumed was straightforward. These magnetic irregularities hint at complex processes deep within Saturn, possibly involving layers of metallic hydrogen, helium rain, or compositional gradients that shift over time. If Saturn's internal structure is evolving, its magnetic field may be a visible symptom of deeper instability. Magnetic fields influence everything from radiation belts to atmospheric dynamics. Changes in the field could cascade through the entire system, affecting moons, rings, and space weather around Saturn. The problem is not that scientists lack theories. It is that no single theory explains all the observations at once. Saturn is presenting a puzzle with too many moving parts. Why the models are failing. Planetary science relies heavily on models. These models are built on assumptions about equilibrium, gradual change, and predictable behavior. Saturn is testing the limits of those assumptions. Cassini's long-term data showed that Saturn's atmosphere, rings, magnetic field, and internal heat output are all varying in ways that do not align neatly with existing frameworks. Scientists can explain individual anomalies in isolation, but connecting them into a coherent picture remains elusive. This is deeply unsettling for a field that values predictive power. Saturn is behaving like a system in transition, but the nature of that transition is unclear. Is Saturn moving toward a new stable state, or is it experiencing episodic instability that will continue indefinitely? Without continuous observation, answering these questions becomes increasingly difficult. The cost of losing our eyes on Saturn. Cassini's mission ended just as these long-term changes were becoming impossible to ignore. The spacecraft that provided the most comprehensive view of Saturn ever achieved is gone. There is no replacement currently in orbit. Ground-based telescopes and space observatories can monitor Saturn from afar, but they lack the resolution and proximity needed to track subtle changes in real time. This creates a troubling gap. Saturn is changing, but humanity is no longer watching closely. Future missions are discussed, proposed, and debated, but none are imminent. Budget constraints, shifting priorities, and long development timelines mean that Saturn may go unobserved for decades. By the time another spacecraft arrives, the planet could look noticeably different. Patterns we once assumed were stable may have vanished. New structures may have formed. The opportunity to observe Saturn's transformation as it happens is slipping away. What Saturn is teaching us about planets. Saturn's behavior is forcing scientists to rethink fundamental ideas about planetary evolution. Gas giants were once considered relatively simple objects, governed by well-understood physics. Cassini revealed that this simplicity was an illusion. Saturn is complex, dynamic, and unpredictable. Its changes suggest that planets may remain active and unstable far longer than previously believed. This has implications beyond our solar system. Exoplanets, particularly gas giants orbiting other stars, may also undergo unexpected transformations over time. Saturn serves as a nearby laboratory for understanding these distant worlds. But unlike exoplanets, Saturn is close enough to study in detail. Or it was. The uneasy silence after Cassini. There is a profound unease in knowing that Saturn's most dramatic changes may be unfolding now, while our best instruments are gone. Cassini's data continues to yield insights, but it represents a snapshot that has already ended. Saturn is not waiting for us to return. It continues to evolve, to shed its rings, to reorganize its atmosphere, to adjust its internal balance. The planet does not care that our mission timelines have gaps. This disconnect between planetary timescales and human attention spans is at the heart of the problem. We glimpse these worlds briefly, then look away, hoping they will still make sense when we return. Why this matters more than Saturn. The real significance of Saturn's changes lies not in the planet itself, but in what it reveals about our assumptions. We tend to think of planets as finished products, stable once formed. Saturn challenges that view. It suggests that planetary systems are more fluid, more temporary, and more interconnected than we assumed. If a giant like Saturn can change in unexpected ways after billions of years, then stability may be the exception, not the rule. This realization forces scientists to confront uncertainty in a field that often seeks certainty. Saturn is not offering clear answers. It is offering warnings. A planet in transition, Saturn is not collapsing. It is not about to disappear. But it is clearly in motion, undergoing changes that challenge long-held beliefs. The danger is not that Saturn will suddenly do something catastrophic. The danger is that it will quietly transform while we are not paying attention. By the time we return, the Saturn we thought we understood may no longer exist. What Cassini revealed was not a finished story, but the beginning of a realization that arrived too late. Saturn is changing, and we are no longer there to watch it happen. 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 Longer there.